Hello everyone and welcome back to the LangGraph Mastery series. In our previous video, we built a React agent that could reason and use tools. But there was a major problem. The moment the conversation ended, everything was forgotten. The agent had no memory. Now, if I told the agent, hey, look, my name is Rio, for example, and then come back later asking the same question, what is my name? The agent would have no idea. So today we are going to solve that problem using one of the most powerful features in LangGraph, that is checkpointing and memory. Okay. So by the end of this video, our agent will remember information across multiple conversations and even maintain separate memories for different users. Let's get started. Now we have already seen most of the imports in our previous videos, but today there is one new import that changes everything, and that is MemorySaver. Now, MemorySaver is LangGraph's built-in checkpointing system. Think of it as memory manager. Instead of throwing away state after execution finishes, it saves it so we can use it later. And that's exactly what enables memory. So again, we'll just load our environment variables, and then we have this state. Every LangGraph application revolves around state. State is a shared memory, as said previously. It stores everything happening inside the workflow. In this example, we only store one thing, that is messages. That includes user messages, AI responses, conversation history, and tool outputs if we had tools. So because we're using add messages, new messages are appended instead of replacing previous ones. And that's the foundation of memory. Just creating a model, and then we'll just create a node. Okay, this node is brain of our application. Every time the graph runs, the function gets executed. And look at this one. This is the system instruction. We are telling the model that pay attention to the user information, remember the names, remember professions, remember preferences. Of course, the model can only remember if we actually provide the previous conversation history. That's where state and checkpointing come into play. And next two lines over here, that's the important line in the node. Notice that we are not sending only the latest user message. We are sending the entire conversation history, which is system message, the previous user messages, the previous AI responses, everything stored in state. So this allows the model to see what happened earlier and answer accordingly, right? So that's why over here we are just returning, the response is returned to the state, okay, which means the conversation history continues to grow over time, right? Now we are just building the graph. We create a graph that uses the agent state, and the graph contains only one node, no tools, no routers, no loops. So the goal of this example is understanding memory, right? And that's what we have: start, LLM, end. A very simple workflow. The user sends a message, the LLM processes it, and the graph ends. And then now we'll look at the magic, which is this MemorySaver. So this single line is the reason we are making this video, because MemorySaver acts as a checkpointing system. Every time the graph executes, the LangGraph automatically stores the current state. Instead of losing everything after execution ends, the graph can restore previous state later. Think of it like saving progress in a video game. When you return later, you continue from where you left off, right? So we're just compiling the checkpointer, and that activates the memory, right? By passing the checkpointer into compile, LangGraph automatically saves and restores state. No manual database code, no custom memory implementation. LangGraph handles everything. We have important thing over here, which is thread ID, right? Thread IDs are extremely important. I think of them as a conversation identifiers, right? Every unique thread gets its own memory. Rio has one memory, Bob has another memory, right? We have two users. And the two conversations remain completely separate. And let's look at our example conversations. Firstly, Rio introduces himself. Then Rio tells us his profession. Then Rio asks, "What do you know about me?" Later, Bob joins the system. Bob introduces himself and asks, "What is my name?" And finally, we just switch back to Rio and ask, "What is my profession?" Right? So if memory works correctly, the agent should remember, right? And now we are just running the graph. We now simulate a real conversation by processing messages one by one. And look at this one, config equal to config, right? So this is where thread-specific memory happens. LangGraph checks the thread ID. It loads the previous state for that thread. It adds the new message, runs the graph, and then saves the updated state again, right? Now let's visualize the process. I'll just run it. And over here you see Rio says, my name is Rio, right? And state is saved. And then, of course, data scientist is his profession, state is updated and saved again. And later Rio asks, "What do you know about me?" So if you see over here, LangGraph restores the previous state, the model sees that his name is Rio and the profession is data scientist, right? And it responds correctly. Now Bob starts the conversation over here, correct? And Bob's state is completely separate. Rio's memory does not leak into Bob's conversation, okay? And Bob's memory does not affect Rio's. So yeah, that's what the video was intended for. So in this video, we learned how state stores the conversation history, how MemorySaver enables checkpointing, and why thread IDs are important, how LangGraph restores previous conversations automatically, and how multiple users can have completely independent memories. This is one of the biggest reasons LangGraph is used in production AI systems, because real agents need memory, right?